Assalamualaikum, Prof. Prof, if you're ready, I think you can start, Prof. Or you want to wait for the others? Normally, we have 80 plus students for science and technology.
Assalamualaikum and good afternoon, everybody.
Good afternoon, Professor. Good afternoon.
Can everybody hear me?
Yes, I hear you.
Yes, sir, we can hear you, sir.
Okay, so I'm not sure if everybody's in the class already or not. Can we start the class or we have to wait for Dr. Nohalida?
Sure, Prof. You can start the class.
Okay, we wait for 5 more minutes just in case any more students coming in. I think it's only 63. I understand there'll be almost 90 students can.
Prof. Yesterday 82. I'm not sure with the today class. So far we have 68. For yesterday we have 82 students. But Prof, some of them are the part-time students. So part-time student, we allow them to join our recorded class later. Maybe some of them cannot join today because of they have a commitment. Maybe.
Okay. Baik. Okay, Assalamualaikum. Good afternoon, everybody. Thank you, Dr.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, I am Prof. Muhammad Faiz from the Faculty of Electrical Electronic Engineering Department. I'm not sure, I think I do not know more of you because you're all from other faculty. Thank you for CGS for giving me opportunity to share my experience on postgraduate students. Okay, so I think today our title is about Module 4, Result and Discussion. Before I go further, just a little bit of myself. I have been working in UTHM, I think, for 26 years. Have been in UTHM itself, I think, almost 31 years, okay, since 1994. So I was actually the first batch of students studying in UTHM, formerly known as Pusat Latihan Staff Polytechnic, PLST. So I was the first batch. And after I finished study, they asked me to come and work here. So I've been here 26 years. I think another 5 more years with the retirement. Okay. I'm not from Johor, I'm from Perak, okay, northern of here. Okay. So to share what I have with my postgraduate students and everybody. Okay. So you can see the photo, that is my FKE building.
Prof, slide are not moving.
Belum
Maybe.
move lagi, belum.
Oh, okay.
Okay. So you can see this is FKE. That's my faculty where I'm sitting now. Okay. Of course, from the picture, it looks much nicer, okay, from itself. This is the notes and assignment I have already put into this folder, so all students can access from it. That's an assignment I have prepared for students to do, and then I'm not sure to submit by tomorrow or in 1 week time. Can give time to submit.
Actually, at the first, our planning is 15 January, 15 January. But if Prof need time to marking everything, some of the lecturers they give until December.
Okay.
Just to mention here that some of the student, actually our degree student, they have convocation next week.
Okay.
So maybe Prof can.
So maybe I'll give some time, okay? Then everybody just submit into the folder. Okay. So this is the content of my talk today. There's 2 days again, today and tomorrow. Yeah.
Yes, Prof.
Okay. So maybe half of it. Okay. So a little bit of my route to PhD. Okay. Maybe some of you are doing PhD, some are doing masters. Depends on your route, but in the end, this is a research foundation. Okay. So I actually did my master by research in UTHM. Under UTM, I was also the first batch of doing the master by research. Then I did my PhD in Warwick. Okay. So this is some of the outline that we're going to look into, especially in the result and the discussion. That is the chapter 4, which is actually the crucial part of all students' thesis. Okay. And that is the part where the examiner will be looking at it longer, spending more time of it, asking you questions, besides chapter 3 of the methodology. Okay. So it's important that when you present this chapter, you have a good foundation and everything in well placed. This is my journey. Okay. When I started my PhD, to tell everybody frankly, at that time, I do not know what is a PhD. Okay, I have a master and started working in Quito at that time. So the university said, okay, you need to get a PhD. So that's where my journey starts. Okay, so I was asked to find a place overseas. So initially, I was looking at US, and then at that year there was this September 11 attack. So in the end, we are all banned from going to US. So in the end, I got a place. I got two places actually. I got in Australia, Melbourne, and then I got from Warwick University in UK. So that's the place where I decided to choose lah, because Australia is a bit expensive in terms of having children and everything. Okay? And my experience as doing a PhD, initially I wanted to do it alone, but then the university asked my wife to do it. So we actually was the first husband and wife to do the spouse PhD program. And at that time, I already have two children. If you look at the photo, my children was very small. I think 3 years and 2 years, or 2 years or 1 year. Okay, so when we wanted to do a PhD together, some of colleagues would say, "Are you sure? You do not know how deep you're putting yourself in, husband and wife, to do PhD together." So at that time, there was no choice. I got the scholarship from MOSTI, and then my wife got the scholarship from SLAP from JPA. So we just went to do the PhD. Okay, so doing a PhD, that is the experience. Everybody have their own story to tell. Okay, so in the end, after all of you have graduated from your PhD, you have your own story to tell. Everybody's story is some smooth sailing, some not so smooth sailing. Okay, so many things will happen along the way. Okay, so we can say that is a PhD or research is the root of life, lah. Okay, that involves a million character, because you will meet many people along the way that's going to help you to complete your PhD, or to help you, to guide you to do some work together. Okay, so and of course after completing, like myself, my wife, we have to thank our supervisor and the people in Stillbury to help us to complete the work. Okay, so these are partly some of my families. Okay, this is when we graduated. Okay, we already touched down in Malaysia after 4 years. Okay, so during the time when we were there, these are some of the Malaysian was helping us to actually survive. Okay, in Malaysia, in UK. Okay, so it's not easy living in other people's country. A lot of things happen, and a lot of things that well, actually, all Malaysians have to work together, okay, to make sure that we are actually helping each other. Okay. This is the 4 years period. Okay, so my PhD was actually not 3 years. The offer letter was 4 years that we have to finish by 4 years. Okay. So this is the Warwick University that me and my wife and my children, we spend time together. Okay. Of course, the environment is a bit different from Malaysia. In UK, there's a lot of place where you can relax and how to say chill out. We say chill out. Okay, in UK, if you are in stress, you can go to some places and just sit down and chill out to look at the environment and scenery. Okay. So this is the words that everybody, all the students, while doing master PhD by research, is the one that you want to hear. Okay, congratulations, you have passed your Viva, and then people say, how do you feel? Okay, but in order to get there, it's a challenging time. Okay, so usually after the Viva, they will say, okay, congratulations, we have discussed and agreed to award you this Doctor Philosophy, subject to minor correction or no correction. Okay, some of my friends have no correction. But with this, okay, as you can see in the photo, me and my wife, we went there 4, we came back 6. Okay, so we came back 6 of us. So we have the 2 children there. One born before starting in the early stage of the PhD, and the baby is the closing of the PhD. Okay, so that's our family. Okay. And of course, these are the words that my supervisor tells me before I come back to Malaysia. So with great power lies great responsibility. So actually, when you get a PhD, it's actually a small knowledge, but also lies a great responsibility. Okay? So that's what my supervisor tells me when on the last day when I meet him. Okay? Doing a PhD or by research, that's the desire. If everybody want to get a PhD, okay, but the fear is there. Okay, some students want to do a PhD because they are in the academician line. Okay, but in overseas, when I was in UK, when I asked around people why they want to do a PhD, they just want to do a PhD. They are keen on studying, they're keen on knowledge, so they don't actually have a rush time to finish. Not like us in Malaysia. Okay, so like me and my wife, we have a 4 years period of scholarship, and then we have to come back and start working. Okay, but when I meet most of the people there, even those colleagues are working with me in the PhD in my room from China. There's no rush. Okay, they don't actually have a job. They just got a scholarship, and then they just study, and then take their time. When they finish, then they find a job. Okay. If they don't finish on time, in the midway, they will do part-time, trying to survive. So that's a bit different. Okay. And of course, if you want to become an academician, of course, that's the first step, okay, to get a PhD. And PhD duration, usually, okay, when in UK, it's between 3 to 5 years. Okay. Of course, I have my friends whose wife, he did 10 years, okay, and some did longer. Okay, depends on it. Okay, and of course, succeed or failure, there's no guarantee. Okay, there's no promise that anybody who embark in the journey of PhD or by research is confirmed succeed. Okay, of course, there's failure. Okay. During my time in UK, I have seen failures okay, among Malaysians. Okay, it's just there's no answer for it. Okay, there was one time there was one Malaysian. He was studying together with us. He came together with us. Then halfway he was not feeling well. Okay, he was having this. Headache and everything. So he asked permission from his supervisor, can I go back to Malaysia to get the medication? So his supervisor, at that time, his supervisor was a very young, energetic supervisor. So he allowed him to go back to Malaysia to get medication. After 1 month, he came back. He was surprised to see that his table and room was occupied by somebody else. So when he asked his supervisor said, you failed. So no reason, I do not know what. He asked permission to go back, and then he just did not finish. Okay? And of course, there are other Malaysian who have studied for 4 years. When he submitted his thesis, very two thick thesis. This Malaysian was from doing law, okay, from the faculty Department of Law. Two very thick thesis, and then we heard that the external examiner was the best friend of a friend of his supervisor, but in the end the result came out she failed. Also, there's no nobody have an idea what happened. Okay, so and there was one of my colleague in my room. He's from UTEM. Okay, his supervisor was actually my co-supervisor. Okay, so he only did one very minor mistake. Okay, when he submitted paper to for conference, he did not put his supervisor name, and I do not know why he tell him. And then when he found out, he has been nagging him all the time. So every time he wanted to see him and discuss his work, he will nag about his why he did not put his name on the conference. Okay, and we were saying, oh, the conference was only just a Malaysian conference, even though international, but not so grand. So I'm not sure why the supervisor was frustrated. And I'm not sure frustrated or angry with him. In the end, my friend, he was there for 3 years with the supervisor, but he came back without a PhD. Okay, so these are some of the stories that I encountered during my PhD lah. Okay, so somebody say doing PhD is like permanent head damage, but it's all just saying lah. Okay, it's just that to ask us to work hard to make sure that we finish the studies lah. Okay, so PhD or master by research is actually a fact like unique process. Okay. And also a life story involving physical emotion change of meaning character. So as I say, along the way, you will get frustrated. You might be crying. Okay, and one day you'll be happy, and another day you do something else. Okay, and we can say relatively achievable. Okay. A lot of people have managed to get a PhD, okay, but of course we need to sacrifice and determination. Okay, so that's why I say some who do not get it, we also do not know what happened. Okay, between he and the supervisor or during inside the Viva room. Okay, and of course there was also one time there was one student. He's not from Malaysia. He's from Pakistan. He did his research work was very fast. I think he finished in 2.5 years. Okay, because his work was related to a company, and this company was giving some grants. So every week have to produce a result for the company. So he submitted his thesis in 2 years, I think, but then University Warwick will not allow him to do the Viva because it's too early. So he waited 2.5 years. He submitted, and his Viva took almost seven hours before he was finally conferred with the PhD. Okay, so we were surprised. We see he got a lot of result and everything, but in the end, his Viva took so long. So in the end, we found out that his external, he actually submitted a lot of papers for journal. And there was one paper accepted, but there was one paper accepted by the journal, but actually the external was one of the reviewer who actually wanted to reject his paper. But because when we submit papers to journal, there are 3 reviewers. So even one reject, 2 accept, the journal will accept. So this external was one of the reviewer who was actually not happy with the method that he used to do his research. Okay, so that's why he took 7 hours to actually give a confidence to the external that his work is actually reliable. Okay, so of course in the end he gets his PhD, but after 7 hours better in the Viva room. Okay, so this is what always happens lah. Okay. So this is a cartoon that we always share when we were in UK. Okay, so the desire and fear, the process of PhD. So so don't worry. Okay, if this happens to you along the way, from Monday to until the weekend. Okay, it will be up and down. Okay, even though me myself while doing PhD, at one day they wanted to do something in the morning, but in the end, after the whole day, we end up doing nothing because we got stuck in some of the process or some of the mathematical equation that we do not know how to move on. Okay, so so that's the place where sometimes your friends or colleague who is around that can help you, or go and see your supervisor, ask how to proceed on. Okay, so in the end, something positive will come out. Okay, and of course, there are times when you get stuck, then you have to just go and enjoy. Like my wife's supervisor, every time during summer break, he will ask my wife to go for holiday. Okay, so like us, because we are international students, and then we have a insufficient fund for our scholarship, so we do not tend to go holiday much. Okay, but her supervisor will always insist on going on holiday to refresh yourself, so that you can come and work much better. Okay, so as I say, during the process, you need to do a few other things. Okay, this is the material supervisor. Okay, so my supervisor is in the middle, this guy, Professor Roger Green. So this is the course supervisor that I told you that my friend did not pass. My friend, he was the main supervisor for my friend. Okay. Of course, he's a bit different. Okay, so sometimes he's friendly, sometimes he's not. Okay. On this right hand side, this is my wife supervisor. Okay, you can see his glass is very thick. Okay, when we give my wife give him some paper to read, the paper when he read the paper is almost he put it very near his eyes to read it. Okay, so you can imagine his eyesight is having a major problem. Okay, but he is a very good supervisor. Okay, he will try to help. Okay, so for you guys, okay, hopefully, okay, all your supervisors, we can say good. Okay, so usually a good supervisor is a person who knows when to stop to his say stop. Okay, to his or her student. Okay, which means that you cannot drag the student for a long time. Okay, provided that the student have some output to be shown as a PhD work. Okay. So this means that he is clear and knows that the level of your work is able to be awarded a PhD. Okay, so I know some in Malaysia, some supervisor, they tend to drag the students long. Okay, I'm not sure what's the reason. Okay, but there should be a limit lah. Okay, because in the end, everybody will get tired soon. When you study, and the longer you take to finish your PhD, for example, you have some new idea, new work. Okay, the longer you submit and tell people that this is your work, in the end, your work could be published by somebody else. Okay, so let's say, for example, you're working on design of a circuit that can get some result of, let's say, 5 gigahertz. Okay. So at that time when you discover it, it's like top notch. Nobody can reach that frequency range. Okay, but if you take so long, let's say another 5 more years to submit and say this is your work, in between you can see so many other people doing research around the world. Okay, so your work could be taken by somebody, and somebody will say, okay, he managed to get 6 gigahertz. So in the end, your work could be a bit problem accepted by other external. Okay, so that's why there's always a limit to it. These are all my PhD graduate students. Okay, so I think almost 12, 2, 4, 6, okay, and 13 students. Okay, so 13 students from 2013 started to graduate until now. Okay. So I have also one more student already complete his Viva, doing correction now. Okay. So of course, all of my these PhD students, each one of them have their own story to tell. Okay? Some are very challenging, some not. Okay. For example, like Dr. Majid Faraj. Okay. He actually struggled. Okay. Because he's from Yemen, no, Libya, from Libya. His English was not very good. So when he started doing master with me, he did master by coursework. Okay, so he did the project master with me. Then after that, when he completed, he came to me and said he wanted to do a PhD, but his English was not very good. On his first proposal defense, his panel was very angry with him. He couldn't. His English was not very good. They could not understand what he wanted to present, and of course, he also did. He did not did much now. Okay, his proposal was very basic. Okay, so the panels did not know actually what he wanted to do. So they actually wanted to fail him on the proposal defense. Okay, but of course, he appeared, and then of course it took a long time now. He finished his PhD in almost 6 years, I think, because of his problem with the scholarship and everything. Okay. Like Dr. Rahman also was also challenging. He lost his baby on the final year. He was writing his thesis, waiting to be submitted. Suddenly he lost his baby, and he was very down. Okay, he did not want to complete his PhD. I have to actually convince and condole him in order to submit. In the end, he submit and finished. Okay. So it was a challenging time. Okay. Dr. Aus and Mayada, they did together, like me and my wife, husband and wife studied together. Okay. So like Dr. Bagandas was very good, one of my best PhD students, published a lot of papers. And he can finish in 2.5 years' time, but he's from Pakistan. But the problem in Pakistan, that they have this funny idea. Whoever finish PhD very early, they consider it's a no good PhD. So in the end, he had to wait until 3 years to submit his PhD work and complete it after 3 years, so that the Pakistan government will recognize his PhD certificate. Okay, so some countries are different. Okay, like Pakistan, when whoever come back with a PhD, their certificate have to be submitted to the Ministry of Education to be checked whether it's really not fake PhD. Okay, and then they will give out another certificate to say, okay, confirm, accept. Then only they can use the title DR. Okay, so some places are a bit different on how they work on it. Okay. Okay, these are my current PhD. Fian under correction, another 3 more. Okay, so I think maybe just nice by the time I retire from academician world. Okay. These are my graduated master by coursework students, by degree students. Okay, so you see, if you are a student, when you submit work to your supervisor, you have to make sure that it's a certain level, okay? Because your supervisor might have a lot of students, and he might not have much time to read, and to read each one of the thesis and everything takes a lot of time. Okay, so so you have to make sure that everything is in order with good result before you submit to your supervisor. Okay, okay, a little bit before we go to the result part and the discussion. Okay, so maybe you have gone through this with other professors in the last few days. So basically, our research category into 5 categories. Okay, so to tell everybody now, there's not much of the fundamental research left. Okay, so I think everything in the world have been discovered and already achieved. Okay, what we actually are doing is we call it fundamental, but it's only an extension of the fundamental research. Okay? So either you integrate, or you modify, or you change, or you improve from the existing research that has been done by other people. Okay? And as I say, exploratory research, new area research, not much is going on. Okay, for example, in communication, they're looking into 6G, okay, 5G area. Okay, so these are more we call it exploratory research. Okay, in other area, civil, mechanical, is more looking into trying to find new materials to replace the current materials. So some of them are using recycled materials, renewable energies. Okay, try to find material to mix around so that we can come up with a new material that can replace current materials. Okay, so that's all we call it the exploratory research. Okay, applied research is more towards you completing something. Okay, maybe you build a robot. Okay? You build something, a machine that can help the people around you. Okay, so there's more applied research now. And development and design research is actually categorized in one of these together. Okay, so mostly now, most of the external examiner, when they become examiner for students, they do not want only to see research by software only. Okay, some external examiner, they want to see something tangible. Okay, hardware that you can prove that is working. Okay, so your supervisor have to be careful when choosing the external examiner or the internal examiner. Some external internal, they prefer to have both stimulation and then hardware to prove it, the proof of concept. Okay? Some external can accept only just by stimulation software, but you have to validate with something else. Okay? So, so it depends. Okay, if you are working on both hardware and software, then it's much better. Okay. So we have this quantitative and qualitative, or you can mix the method of your research. Okay. So because in order to, because we are talking about results and discussion. Okay. So in order to generate more result, okay, so you need to have both lah. Okay. Mix of quantitative and qualitative. Okay. So quantitative research is mostly through experimental. Okay, experimental, you design something and then you test and see whether it works or not. Okay, qualitative is more towards theory. You formulate equation, okay, and then you use software to put in some data, then you stimulate out to see whether the result is good or not. Okay, so if you are working on this qualitative research method, the data that you generate, which means that the parameter that you choose have to be reasonable. Okay, which means that we have to be, if you, let's say you are taking some value from the component, so you have to really actually get the data from the actual component and put it into the simulation. You cannot simply put in any numbers because simulation software, you put in any value, they will just generate out result for you. So because some external, they will say, oh, the value you put in is not acceptable because it's too much. In real world, you cannot reach that kind of value. Okay, so you have to show them the value you put in. It can be applied to the real world and can be done to fabricate something tangible out. Then only consider good research output from the qualitative research method. Okay, so or you can mix both of them. Okay, so my student, most of them, like Dr. Bagan, his work is a mix. It's got hardware, software. Okay, like Dr. Majidi, he was doing image processing, something like computer science. So that was take some time now, okay, to actually prove the concept of the method that he used. He was using contour method, how to put digital watermarking into a picture and then try to send the message, and then with the digital marking, when the other side reach it, he will have a key authorization to open that digital watermarking so that to know that it's authentic what he sent. Okay, so that is more towards the software part of it. Okay, and of course, if you are doing survey, so usually education students they will do survey lah. Okay, if you are doing education studies, so survey is you have to come up with questionnaire. Okay, so usually for the science technology, we don't have much questionnaire to be done. Okay, so we are all mostly tangible. You have to go into the lab and combine some materials, okay, to make it work. Okay. Okay, so after you have confirmed your method and technique and everything, so this is the important part, okay? Measurement and data collection. So when you start doing measurement and data collection, so of course, first you need to make sure that you have the equipment to do it. Okay. So the equipment that you want to measure what kind of output. So for example, if you want to measure core body temperature, so make sure that you have the integrated capsule and everything. Okay. So then after that, what parameter you want to measure? Okay. You want to measure the change of the temperature, or you want to measure the metabolic when the temperature affect the material. So this is also important. Okay? So the parameters, it depends. Okay, some are on environmental parameters, some on electrical. Okay, so those who are doing power, so they are mostly about you need to have the meters. Okay, they can do the measurement and then get the output measurement. Okay, so in the end, you will have two types. One from the data collected from the real equipment, so you can consider it hardware measurement. And then if you have a software that also can stimulate something like the hardware, so we can call it simulation data. Okay, so there will be two types of data which you can use to compare whether you have achieved what you want to achieve or not. Okay. The rules in measurement theories, okay, so there's rules apply. Okay, we can do the method of directness. Okay, okay, a straight way you measure. Okay, or you can use different levels, different levels of measurement. So by, for example, you can change the frequency of from 1 kilohertz to 500 kilohertz. Okay, or you can also use. There's always some error, lah. Okay, so when you do measurement, there will be some error where you need to compare whether this is correct or not correct. Okay, so and then in the end, what you measure is it reliability, and then can be validated. Okay, so these two keywords is the in the end is the two important part that you need to compare and show in your thesis. Okay, that whatever data you presented is can be acceptable. Mm-hmm. So method of measurement, there's so many. Okay, you can do direct method. Indirect method means that not to say not correct way. Okay, sometimes some measurement, if you follow the flow of it, you will not get the output. Okay, so you might have to do a bit of changes on some part. We call it the indirect method. Okay. Or you can do the comparative method, okay, to compare between two substance, okay, or two different materials or two different values to see what changes to the output of your system. Okay. Of course, there's also this coincidence method. Okay. Okay. So like Albert Einstein and everybody, okay, they try, and then suddenly they found they bombard something, and then some output changes coming. Okay, so nowadays I think quite rare lah, okay, to get coincidence method. Okay, usually what we have done is all mostly established. Okay, so it's only we need to change some variation to get it much higher or better output of it, of the system only. Okay. Okay, directness of measurement. So we can say direct and indirect. Okay. So direct, of course, is much better lah. Your result will be very concrete. You know, objective of what you want to measure. Okay. So for example, weight, demographic, you already know how much to weight. You just want to do measurement to confirm that that is the weight that we're going to get from it. Okay. So if it's indirect, it's very abstract. Okay, it's something like try and error. Okay, so for example, you go to the doctor and say you have depression. Okay, depression is indirect. Okay, a doctor cannot actually diagnose what medicine to give you. Okay, so that's why he will ask a lot of questions. If you have pain, some symptom somewhere, then it will move to the direct approach lah. Okay, so otherwise it's going to be a try and error. Okay, so that's why sometimes when you go to the doctor, when you say your depression, the doctor will say go back and take a rest and go to sleep. Okay, so because he cannot simply give you something else than unknown what you want to treat. Okay. So it's the same thing when we do in engineering. Okay, if you want to combine two materials, you have to make sure that both of the materials you combine to become a new material have the same characteristic and can be combined. Okay, otherwise it will be a waste of time by putting it together and then there's nothing coming out of it. Okay. So usually direct method, as we know, is directly compared against a standard. Okay, so that's why it's a concrete and objective. Okay, so indirect is always not always possible, but it can be feasible and practicable. Okay, so that's why sometimes when you tell people you do this kind of way, and when it's not according to standard, people will feel that you might not get the correct answer, okay, or you might not get the result that you want, okay. But of course, it's feasible to try, okay. So you can just try and see whether you can get the result. But after getting the result, then you need to have some answer why it becomes like that and what to do with that answer result, okay. So basically, these are the two measurements that you need to go through. Okay. Sources of error. Okay. Measurement error always occur. Okay. So for example, if you take a 10 measurement, suddenly the first 5 result shows positive going up, and then suddenly in the middle parameter, the thing will drop, and then after that it will go up again. Okay, so you were hoping that the result was positive and going up directly, increasing all the time. Suddenly there's a drop in the middle where you cannot answer is it correct or not. Okay, so that could be the source of error. So if that things happen, what you need to do is that you either repeat problem data that you feel that is incorrect, okay, or maybe the drop is the one that's correct and the rest are incorrect. Okay, so that's why you have to continue doing random testing again to see that there's any difference or not. Okay, so random error, the difference is without pattern. Okay, so systematic error, you can see that the measurement is almost the same every time you do it. Okay, so if this occur, then you know that the method is incorrect because it's a systematic error. But if it's a random error, then it will process will give a challenge to you, okay, to actually prove that in the end which is correct and not correct. Okay, so final question. Very quiet. Okay, next part is reliability and validity. Okay, so every time my students give me result, okay, so I always ask them, okay, is this result correct? Okay, some students when they manage to generate some output result or they put in something, show some measurement, they are very happy already. Okay, I think it's already workable. Okay, so of course they haven't like changed the parameter or they haven't do other testing yet. Okay, so that's where we come in, the reliability and validity. Okay, so reliability means that it must be consistent. Okay, so every time you do that measurement, you get almost a similar result. For example, you test a solar panel, it gives you 10 watts. Okay, after doing a few cycle testing, it's around 10.1, 10.2, okay, or 9.9. Okay, so it's roughly near the area. So then we can say it's reliability consistent. Okay, and then after that we need to validate. Okay, does the measurement hit the bullseye? Okay, so validity means that if the thing really actually giving 10 watts, okay, or maybe when you before you use the material, you study its characteristic, you see it actually can give you 15 watts or 20 watts, okay, but every time you measure it's only 10 only. Okay, so there's a huge loss in between that. Okay, so this also you need to prove the validity that it's okay. Okay, so it's reliable and valid, then your result will be confident. Okay, but it's reliable but not valid, then your result is not in the bullseye. Okay, either reliability or valid, then it's more in troublesome. Okay, so your result is all scattered around with a place to say whether this is correct or not correct. Okay. So for data collection strategies, okay, how do researchers actually collect the data they need? Okay, so of course those who are doing engineering or sciences, okay, so we always use measurement. Okay, as I say, only those doing education line or business line, they will do the survey questionnaire interviews. Okay, so engineering, science and technology usually will measure or will do stimulation to collect the data they need. Okay, so the strategy for collect data depends on the research design that you have actually chosen. Okay, whether it's a qualitative study or quantitative study. Okay, so or it's a mix of both to actually come out with an output result that is suitable for your research. Okay, so this is for you to answer and look at your work, your research work, which is much better. Okay. And then this data strategies, okay, so it's usually more effective, okay, if you use previous developed tools. Okay, so what it means that when you start your research, don't start with a zero, okay? Which means that I always ask my student, you have to read other people's journal papers, okay? Other people's research work, and see what they have done, and then try to fabricate what they have done in your simulation or in your test measurement. Okay, so that is usually the first strategy. Okay, so from there you will gain some motivation and say, oh, okay, what these people have written is workable. Okay, so from there you might get an idea how to modify or integrate to change to get a better thing. Okay, so that's the first thing. Okay, more effective to use previous developed tools to establish this reliability and validity. Okay, so so for example, nurse, when they collect data from patient every day, okay, so they will use psychological measurement, observation measurement, okay, and then they write self-report. Okay, so this is true. When my son, my children were born in UK, in their hospital, I see the nurse there almost every hour, every half an hour, they will come and check my wife, collect data, and then they write down, okay, before the birth of my children. Okay, so with this data, when doctor come when it's near to birth, they will know whether what situation is it going to be normal, or you have to go for surgery. Okay, so it's the same thing. Okay, that we should apply in our research. Okay, so you need to do observation measurement. Okay, to see any changes. And every time you do this same testing, you get the same output result. Okay, so guess what? Okay, researchers use the same strategy for data collection method that nurse use every day. Okay, so that's what we say, okay. Observe, and then psychology measurement. Okay, so test many times, and then write down. Always write down. Okay, every time you do measurement, you have to write down. Okay, what date this measurement has been taken. Okay, and what have you get from there, and then when the next day you come and take the measurement again, you see any changes happen to your system or to your combination of materials. Okay, so this is important. Okay, so make sure you jot down. Okay, don't measure and leave it. If you want to see changes, then you take a photo of the changes in terms of color and everything, okay, so that you have proof. Okay, because when the time comes for you to write the thesis, you should be having a file full of data everywhere. Okay, for you to slowly analyze which data is important and then can give you a good output result, so that you can put in your thesis. Okay, it might not be all the data that you collect that we put into the thesis. Maybe some part, some is not relevant, some is good data, some is not. Okay, so but you should have a file. Okay, to make sure that all the data every time you collect and write down. Okay, so psychological measures. Okay, so this one is, for example, measure using ECG. Okay, so this is using equipment. Okay, so you measure many times, you see any changes or not. Okay, and then if microbiological studies, okay, who are from property science, if you are doing biological, so you can see the culture, the sensitivity, any changes not from this biological measurement here. Okay, so you have to take note, okay. So maybe today, day one, some of the bacteria have made some changes to the solution. Okay, day two, more survey of the solution. Okay, and then day three, what happened and so forth. Okay, observation measures. Okay, so this is very unstructured, okay, because we just observe only, and also very subjective. Okay, We just look at the changes and see whether any changes or not. Okay. But even though observation is unstructured or subjective, we can also make it structured observation. Okay. By putting objective to it. Okay. So you say, okay, every 5 hours that I want to see if there's any changes to this solution or not. Okay. So then this one become an objective observation. Okay. So which means that every 5 hours you will come and take a measurement to see any changes to the solution. Okay. So then you become a category system, and then you have a checklist, and then you rate the scale. Okay. So even though, as I say, observation is unstructured, but it can be structured, depends on how you put it and how you structure it. Okay. So usually, like my students who do solar panel studies and setup, okay, so they have there the microbe in that leg there. Okay, so he has to take every 1 hour. Okay, one session in the morning, and then one session in the afternoon, and then evening. Okay, that day he went in the middle of the night, so I was not happy too late. Okay, so I say just take in the morning and afternoon and see any changes. Okay, so we make it a structure objective. Every hour there will be a data every. Okay, self-report. Okay, this is all students. Okay, PhD, master, you have to learn how to write a self-report. Okay, self-report is not asking you to write the thesis, but it's just notes that you take notes. Okay, and of course, this self-report you can put it structured and unstructured. Okay, and this self-report will be good when you want to start writing your thesis. Okay, so because some experiment data you have taken like first year, second year, and then third year you are doing some other experimental, so you might have forgot already. But if you keep a self-report, then you can refer it back. Okay. Okay. Collecting engineering data. Okay. So there's 3 basic methods for collecting data. A retrospective study using historical data. Okay, so this is means that you have to look at previous research work. Okay, what they have done in the area. Okay, so that either you want to do it again to repeat the test to prove that it's viable, or you can look at the way they do collect the data, and then maybe you change some parameters so that it's be different from them. Okay, but usually I always ask my student they have to repeat what other people researchers have done first to prove that thing exists. Then only they can modify or change something else to make it much better. Okay, so and of course, another way is the observational study. Okay? Or you can design an experiment. Okay? You make a setup experiment to test a few testing equipment. Okay? So it's up to you. Okay? You can design your own experimenter. Say you want to measure this output, another output 1, output 2. Okay? One maybe taking the current, another one taking voltage. Okay, so that is design experimental. Okay, this is another way. Okay, so if last time when we study physics and everything, so you set up something like this. Okay, this is one of the measurement from the mechanical side. Okay, so you have the condenser, the coolant, and then from the boiler. Okay, so put in steam, and then you see how much temperature will go up, and how much it will draw to pull this strength up. Okay, so this is what we call setting up a system. Okay, you set up a system and then try to measure out whatever parameters that you want to measure from here. Okay, so external examiner like this kind of work, setting up system. Okay, so of course, if you manage to set up a system and it's workable, then it will be a plus positive output for you. Okay. Okay, retrospective study. Okay, so this one is either or sample from the geographical process or from some period of time. Okay, so the objective of this study is to actually to show the relationship of, for example, two temperatures, two reflux. Okay, and to see whether there's any effect or any contribution to the output. Okay. So in most study, engineers usually using this data to construct a model. Okay. So which means that you're trying to come up with a new model. Okay. So as I say, when you want to come up with a new model, you have to start from other people's model. Okay, and then use their own parameter, and then set up to see it's running, and then from there to come up and develop a new model. Okay. So like Dr. Bagan does, he was setting up a system. Okay. You know, in fiber optics transmission, we have the transmitter and the receiver, and then we have amplifier. Okay. So current system is using amplifier which is converting from electrical to optical and optical to electrical. Okay. So his work was actually to develop amplifier which is all optical. Okay. So there's no conversion from electrical to optical. Okay. So in the end, he managed to do it. Okay. And I think his work got patent. Okay. We got a patent granted from it. Of course, it costs a lot, okay, because we have to buy components and set up and design our own component and set up our own system for it. Okay. The observational study is simply to observe the process. Okay. So this is usually been done mostly those who are studying biology, chemical reaction. So usually we'll use this observational study. Okay. So if other engineering students who set up system, they will use this retrospective studies. So design experiments. Okay. There's quite a few. Okay. You can replica from previous work. Okay, and change a few components from it to come up with a better output. Okay, or you can factorize the experiment. Okay, maybe the whole system experiment from other people. You change one part of it. Okay, so that it will become much better. Okay, so this is the type of design experiment. Okay, either fractional factorial experiment. Or one half fraction, okay, maybe half of the system you change, and the other half you remain the existing one, okay, or only one fractional of the experiment you change, and then the rest following the same. Also, it's possible, okay. So in the end, to get a PhD, you actually need something new, okay, some genuine idea of your own work, okay. For master by research, it's okay if you only modify something, okay, or replica others people work, okay. You don't need to have really something new, okay. PhD work, in order to get a PhD, you have to actually show that you have actually achieved something that not have been done by other people, okay. Not to say totally new, but at least some part of the element is something different, okay. Okay, so collecting data, this is what you need to show. Okay, if you are designing a new system, okay, plot the graph, okay, draw tables, okay, and then do mathematical calculations. Okay. so that you can collect the data. Okay. So this one is a design of a distillation column. Okay. So if you are designing a new distillation column, so you have to show why you choose this design, why this uh, size of it. Okay. Why not different size? Okay. What you intend to achieve. Okay. And then from there you do 8 testing run. Okay. And then you change the factor and see what does it have output of it. Okay. So you must have something like this. Okay. In your thesis to show that you are in engineering. Okay. Doesn't matter which part of engineering, but if you are doing design, this is some of the way to show okay, your engineering data of it. Okay. Okay, and then to get more data, okay, you can change the rate temperature. Okay, so and then you plot the graph, concentration, lux rate. Okay, so we can plot this temperature to see there's changes or no changes. Okay, so this is a two-factor interaction, means that you plot two data in one graph. Okay, to show that there's a difference between the changes of it. Okay. Some students, last time my students, when they first started, they like to plot one graph. Okay, so one graph, I say you cannot see the difference. You cannot show the examiner whether you have improved the system. Okay, so this is what usually people plot two-factor interaction. Okay, so have two. Some have many graphs together. Later on, I will show it's like that you can plot together and to see that your work have really impact from other people's work. Okay. Okay. So more of this. Okay, you can show the design a 4-factorial experiment distillation column. Okay, a factorial experimenter. Okay, so we can change the size and see what happened to the revolt temperature. Okay, so this is the input concentration. Okay, so all this step by step you have to show and proof. Okay, as the collection of engineering data. Okay, so you cannot only run one data and it's enough to get a PhD. To get a PhD, you must have. Usually my student chapter 4 will almost have 30 to 40 pages of result of different compilation of result and different testing to show that the system that they have proposed is actually working. Okay, so that is to convince the external panel that this is really workable. Okay. Okay, of course, during collection of engineering data, you can also do random samples. Okay, random samples means that you can select from a population, and then you can change the sample size. Okay, so for example, that day, Dr. Wafi, he was designing the railway track. Okay, the railway track with wireless communication. Okay, so his sample was actually to change the railway track. So he designed initially one single track and then double track. Okay, and then there was a triple track. Okay, so he extend more track and see what happened. Okay. So these are all random samples. Okay. And then he will actually try to change the distance between the train coming to the transmitter sensor and see what happened. Okay, so the farther the distance, what will happen to the communication? And then he changed another one. He changed by controlling the train speed. Okay, the speed of traveling towards to the transmitter. Okay. So higher speed, what happened to the output of the system? Okay. So this is what we call random samples, okay? And the population size and the random size depends on it. How many data sets are sufficient for PhD study? Usually, data set that you need actually minimum 10 lah, okay? 10 to test the validity of it, okay? So for each of the data set, let's say for example, just now we did the distance, okay? For example, we do parameter, we change the distance of the parameter. So there will be 10 data set. And then we change the speed of the train, so another 10 data set, okay? And then after that, we changed the power of the transmitter and the receiver. So another 10 data set. Okay. So there's already 3 different data set to be shown to the external examiner. Okay. And then for that, that was for 3 different data set for one single track. And then we did it for another system, the double track. So another 3 sets. So that one would be 30, and then there was the 3 track. So almost 90 data set already of different parameter, just to show the concept of that wireless communication between a train and to the base station. Okay, you get what I mean? Okay, this one interview is actually more towards, as I say, educational studies and those doing entrepreneurship business. Okay, so I think for engineering, we don't do much interviews. Okay, but if engineering, if you want to do interviews, it also can. It's not the interview as the data set, but the interview is just to get the idea of the concept. Okay. So, for example, if you are designing for civil engineering, you are designing a structure, beam, and everything. So you can just go interview all those contractors, okay, and ask them what type of beam can be used, okay, and how far the beam is, okay, and the different set of it, okay. So this interview is not considered a data set, but it's a questionnaire that can help you to get some information on how to proceed. Okay. The master sample untuk interview and questionnaire berapa cukup? Master and PhD almost same lah. Okay, if you do interview sample interview, usually almost you need at least to have 50 sample lah. Okay, interview people, 50 people to answer the questionnaire. Before that, it can be considered validity of reliability answers lah. Okay, so if measurement 10 is okay. Okay, but interview, because you have different people to interview, and then the more you get, the much better, because if you interview only 10 people, and if the 10 people say all different things, then you do not have something relevant to concise. Okay, so at least, of course, the more the much better, okay, but you can say a minimum 50 people, so that you can see the variation of what people comment, okay, from the questionnaire. Okay. Okay. Okay, questionnaire survey. Okay. When you do questionnaire survey, many factors need to be considered in developing questionnaires and survey. Okay. When you develop this questionnaire, the language, the reading level, the length, clear instruction must be clear. Okay. I was an external examiner for UTM and a few universities. And of course, they always do this questionnaire to survey graduate employment, GE, graduate employability. So you see, everybody is human, yeah? Okay. If you ask too many questions, let's say somebody give me some questionnaire and there's like 10 pages to answer, I also might not answer for her, okay, or him. Okay. So all those questions must be short, must be clear what you want to ask, okay, because the language can must be understandable. And, what you want to achieve, okay. Sometimes we read this question from people. We thought that he wants something like this, but actually he wants another thing. Okay, so like for example, the question GE, some of university they ask, okay, how long have you been working here? So that's all too direct. We cannot actually perceive whether he has actually worked there for a long time or just a short period. Okay, so they should ask, have you changed job recently? Okay, so that they know that they are tend to one place or not. Okay, so questionnaires may be distributed. Okay, either by email, but usually email. Okay, so I also sometimes get a lot of questionnaire from email. Okay, so as I say, if it's too long, people might not answer. Okay, so unless you call them directly one by one, then they can answer for you. Okay. So the next part is any more question before me? So the next part is what do you do with the data collected? Okay. So some people like my wife always say his students study master PhD for 2-3 years ago. When my wife asked them, have you got any result data? They always say no. Okay, but then when asked to produce and show her, it's actually there's a lot of data. Okay, so sometimes a student do not know what to do with the data collected. Okay, some will just do measurement, and then do various testing. Okay, what the supervisor asked to do, he just do, and then keep all the data before doing know what to do with the data collected. Okay, so this raw data. Okay, so actually you don't have to wait until the final year, third year to start processing or analyze your data. Okay, so actually after every time you do one cycle of the process data, the data you get, you must actually straight away process and analyze it. Okay, to see what is the outcome, and then so that this data will help you to change. Like, do you need to modify the experimental setup, or do you need to modify or change something else? Okay, some students they collect, and then they wait for second year. Maybe some third year only they want to start analyzing. They say, okay, I want to do all the experimental first, then I don't want to go to lab, and then I want to sit at home and analyze it. That is going to be a problem also. Okay, because if you wait too long and then you analyze, while you analyze in the third year or end of second year, and you found out that there's a lot of irregularities of your result, and then you want to go back to the lab to set up what you have done before that, you might not remember what you have set up. Okay, or maybe the setup equipment, some of them might be borrowed from other institutions that you have to return already, and you cannot do it again. Okay, so it's best every time you after one set of data, you straight away go home and then you plot a graph, okay, and see what happens to the result, okay, any changes, any positive output, okay. So and then straight away present it to your supervisor to see you can comment, okay, whether if good enough or not, then can proceed to the next level. Okay, if not, then have to start again. Okay, so and of course, some student, some supervisor, they ask their student after getting one set of data, straight away write one journal paper or one conference paper and publish to tell the world or people that you are working in this area. Okay, so do not take so long. Okay, so this is important lah. Okay, so straight away process or analyze after one set of experimental, and then try to present it. Okay. So processing your data, okay, either you organize manually or you use your computer, okay, and of course you also need to record using keyword, okay, so that you know which data is for which set. Okay. So like that time, like Dr. Wafi, I told you, they almost have 90 set of different data. Okay, that day when he finished his PhD, and now he's working in Saudi Arabia under railway, the Mecca and the Medina line. Okay, so if you go to Mecca, Medina for Umrah and Hajj, then if you go on this the bullet train, so he's working for the company now. And when he gives me the data, I myself also got headache again because there's so many data from his file. Okay, so and all this data, of course, he managed to produce and isolate out. Okay, but when he give me the whole chunk of data, he say I can use this data to plot something else. It's true okay, because there are so many parameter different set of it. Okay, so as I say, need to record, okay, and categorize in picture to see how to process it. Okay, and of course, presenting is to turn the data into comprehensive pictures, which is either two things only: table and figures. Okay, so table and figure means table you put in data table, and then the figure means either in graphical form, okay, to show the output and the changes of the system parameter bit, okay. So these are examples, okay. Of course, if you use Excel, there are so many, but of course, not everything is suitable. You need to see what type of experiment that you are doing. Okay, some can be performed in bar chart. Okay, but usually, if electrical, mechanical, usually we plot in terms of line. Okay, line graph. Okay, to show the trend on how the data changes and everything. Okay. So if bar chart is good when you want to compare a discrete item. Okay. So let's say compare two different things. One maybe using measurement experimental work. One using simulation software. So then you can compare. Okay. But otherwise, usually line graph is the much better solution. Okay. Some like this, okay, pie chart, okay, but pie chart is usually only to show the portion of various part only, okay. So seldom okay. If in engineering thesis that so far I've read, seldom people use pie chart to demonstrate the result, okay. Table is useful, okay. Tables you must have a lot, okay, to actually compare between different data and parameter, okay. So table must be labeled correctly, and then to tell what this table actually trying to tell people, okay. And besides all those tables and everything, these are also good, okay, to be in the thesis, okay. But of course, if you take this figure from somebody else, then you have to cite or reference it, okay. If you are able to redraw it, okay. Some of my students like Bagan, the day when he was doing the fiber optic system, he redraw the system by himself, okay. So when you redraw, then you don't have to reference. It belongs to you, okay. You change some part of it, okay. So all these figures are important, okay, especially in chapter 2, okay, chapter 3. This will be a guideline so that when you want to answer anything discussion of your result, you can refer to this chapter for validation or confirmation of the result, okay. So drawing and diagram can be used to enforce supplemental textual information where something is more clearly shown in diagrammatic form, okay. And photo also can be show to help illusion. Okay. So especially usually my student when they do this block diagram, okay, they actually come up with develop a system. So when they draw block diagram, so I always ask them don't use only boxes only. Okay, so when they draw block diagram, let's say the block diagram is referring to an IC chip. So I say put a photo of an IC chip there in the block diagram to show people, okay, this block is actually representing an IC chip. Okay, so then the picture will be much more alive compared to just only block and ask people to read the words there. Okay, so when people look at one look at the page of your block diagram, then he can see that it's actually a whole block system consists of different element component. Okay. Okay. Next, when you're presenting data, layout and labeling, okay, all these must be correct, okay. So every time I become external or internal when I read student thesis, all these usually some student either they miswrite because so many pages can, okay. Some thesis 300 pages, some 200 pages, okay. So you have to make sure that all the graph, chart, drawing, all must be numbered consecutively as figure, okay. If you use figure 1, figure 2, figure 3, so continue, okay. Some, let's say figure 1, in chapter 1, it will be figure 1, 1.1, 1.2, okay. Chapter 2 will be figure 2, 2.1, 2.2, and so forth, okay. So in Malaysia, most of the thesis, everybody like to put it in about 5 chapters, chapter 1, 2, 3, 4, 5, okay. So 1 introduction, 2 literature, 3rd methodology, 4th is the output result, and 5 is the conclusion, okay. So like my thesis in Warwick, I have 10 chapters, okay, because I do not follow the sequence of these 5 elements, okay. So my thesis was according to the work I have done, okay. So I designed circuit 1, it will be, of course, chapter 1 is introduction, chapter 2 literature, and then chapter 3, the methodology, I break it into a few chapters, okay. So chapter 3, first part methodology will be design circuit number 1, then chapter 4, design circuit number 2, and then the next one, design circuit number 3, then only after that, the result and the conclusion, okay. So overseas is allowed to have a different way of presenting, okay. So but I think in Malaysia, people like to see the standards, okay. So make sure everything will be labeled correctly so that it's important because examiner will be frustrated, okay. So like for example, he was reading something and say, okay, you write there, refer to figure 2. Then when he turn it figure 2, it didn't look like the figure that you are describing in your sentence, okay. Then later on when he read further, he found out, oh, this picture is actually referred to the statement that you write, okay. So with this small minor thing, it might affect the output of your Viva, okay. So make sure that all is labeled accordingly to what is supposed to label, okay. And then title and caption, okay. Title and caption is this one, okay. This one, figure 4.4, that is schematic diagram of human heart, okay. So very concise and straight away explaining to this, okay. So I know a lot of students, they like to do long figures, okay. Figure 4.5, this figure shows power which is this, okay. So all of this must be short and concise and direct to the point, okay, and really describe the subject and the data illustrated, okay. So that's important, okay. First letter of the word, title should be capitalized, and then the title of table should be on top and title figure bottom below, okay. So like this, okay. Table on top, figure below, okay. So even though this is minor things, but it's important, okay. Let's look at this. comprehensive of drinks sold in 2007. Okay, so very direct to the point. Okay, like this one, most prefer reading material by engineering student in percentage. Okay, so these are things that you should look into. Okay, labels of part in the illustration should be clear and concise for a few words. Okay, so that is moving towards to generating your data and everything. Okay. Okay, so look at this following image. Okay. If you can identify how they could improve, be more suitable for academic report. Okay. So can you see the difference here? Anybody? So you can see the first one here. Look, there's no x-axis. So this one, look, you have to label here. Okay, and then okay, Bacha has no label on y-axis and a very weak label on the x-axis. Okay, just like write this condition 1, 2, 3. So examiner do not know what does it mean. What does condition 1 means? Condition 2 mean? Okay, so like this, condition 1. Okay, you say okay, incidental phase false belief does. Okay, condition 2, implicit belief and relative tracking. Okay, so this more direct and explain in more detail. Okay, and then of course the color of the belief bar and the background makes the graph difficult to read. Okay, so there's no overall title of the graph. Okay, so so these are all important when you label graphs, and of course even last time when my student when they submit thesis, usually after 4 time reading only I approve to go for pre-viva or viva. Okay, so the first draft is always terrible. Okay, of course as they move along, then, but of course usually the first draft I always ask my student to put everything in. Okay, whatever data he feel that he want to put in, just write into the thesis, and then I will read through and then tell him, okay, this is this no need, this is required, and how to arrange that. Okay, so because last time when I write my first thesis, also my supervisor said the same thing. Okay, just throw everything in what you have done throughout, what you have achieved, everything you write according to you want to write, and then check everything in, and then when the supervisor read, then he will know which is important and not important. Okay. Okay, so always remember this. Okay, even though you write a journal paper, conference paper, also same. Okay, make sure that do not have all this just general statement. Okay, general statement that do not lead the reader to where he wants to go. Okay, do not tell in detail what is it about. Okay, and of course, thesis. Okay, if you have some money, the final thesis that you want to send to the external, if the graph in color, print in color, please. Okay, it make a difference. Okay, I know some you want to, it's expensive. Okay, print in color, but if black and white, sometimes, for example, the one that is in line. Okay, like this one line. Okay, so if black and white, if let's say like this is okay, it's two different graphs. Okay, sometimes when you plot the graph, all are very identical and very same type of graph. Okay, so you cannot differentiate. So if you don't print in color, you print in black and white, then you cannot see the difference. Okay, so never save some money. Okay, you need to which are in color, print in color, so that it's easy for the external to read. Okay. Okay. Next is table. Okay. So table, make sure there's a line like this. Okay. So if you want to put like this, it's very hard to understand. There's no grid line. You do not know which line is equal to which line. So, and there's always no label. What is it about? Okay. So make sure all table form are in. You have this line. Okay. If you don't want the dark line, you can have the very. I think Microsoft Word can put in a light, soft, dark line, gray line behind it so that you can see the difference between the lines. So when people read, they will know, okay, for mathematics GCSE, those who get B and C, how many students, how many, and so forth. Okay, so this is also important. Okay, especially when in presenting in your chapter 4, your graph, everything, all this must be in order. Okay. Any question until now? What steps should I take to ensure data quality is valid? Yeah, I'm coming to it in a few slides, I think. In a few slides, I will talk about this reliability and validity. Now it's just only the beginning of it. Okay. There's almost 100 slides here. Okay. There's some. We have. I think we have on discussion and everything. Okay. I think in a few more slides will come to this valid and reliability. Okay. Okay, Anoin. Okay, next is evaluation. Does UTHM have any Scopus Index journal? Yeah, we have one. You are from which department? You are which faculty? If IJIE, if you are from mechanical, electrical, and civil engineering, you can submit to IJIE, Integrated Journal. I forgot the name. IJIE, International Journal Integrated Circuit or something like that. Forgot. Okay. I'm one of the editor for the electrical side lah. Okay. So this journal is Scopus Index. I think we are in Q3. I think we just got Q3 last year. So this journal published 1 year 3 times, and each regular issue is around 30 papers, 10 papers from mechanical, 10 from civil, and 10 from electrical. From FSKTM, I think also recently got the Scopus Index. I think forgot the journal computing. I think I forgot its name, but now currently in UTHM, I think this the 2 journal which is Scopus Index lah. General Computing and IJIE. Okay. The rest all journal already established but have not. One more year, Journal of Technical Education Training. Yeah, 3 journal. Yeah, so 3 journal Scopus. Okay. So the rest, there's a lot of journal that already established, but they have not able to get index Scopus yet. Okay. Because to get index Scopus, we need at least 5 years, I think. 5 years of continued publication from the journal, then only can be indexed. And then it's not so easy to get indexed because we cannot publish everybody's paper in UTHM in that journal. Okay, so the journal to get index Scopus, we must accept papers from all over the world. Okay, so the Scopus will actually check and see what type of paper that we publish. In fact, each regular issue. Okay, so we always must mix with overseas, some local university. Okay, of course they want to see more overseas lah. Okay, so for internal papers accepted, maybe a few percent lah. Okay, can be accepted. Depends on the reviewer comment. Okay. Okay, next part is the evaluation part. Okay, so after you have collected the data, you need to go to this evaluation phase. Okay, so this evaluation phase is actually the purpose is to determine okay, the effectiveness of your model or your program or your material that you have used. Okay, so questions that are originated from the key when you start your PhD, your objective that you want to do. This question is the one that you see from this evaluation whether you answer the question or not. Okay, So these are the questions that you need to check lah, okay, from your data collected, and when you evaluate, have you really answered the question? For example, the first objective you say, okay, to develop a system that can transmit 5 gigahertz frequency, okay. So you do the design, you do the simple testing, and then you check have you reached the 5 gigahertz or not, okay. So that is the evaluation part, okay. And then after that, you need to check the quality, okay, the importance of this finding before you make any decision, okay. Which means that after you achieve, let's say you target 5 gigahertz frequency, and then you manage to get 4.9 gigahertz or 5.1 gigahertz, so very near. So then after that, you have to judge, make decision whether this is valid or not. How to judge valid is to actually later to actually compare with other people's work and see that this is relevant or not, okay. And then the last test is to test the value, okay, the usefulness of this improved efficiency. Okay, so you have to do a few other tests to test and show that your system is actually much better than other people's. Okay, so compared to the initially research, okay, when you start your research, it's only you want to test a theory, okay, or produce some finding on it, okay, and then to judge and check with other people work whether it's okay now, okay. So this evaluation part is important to make sure that what you have done is viable and reliable, okay. So evaluation of this research, when you do evaluation, you need to understand the model, okay, or the production that you can see the evaluation study, okay. So like me, when I viva for my PhD, my work was to design the receiver circuit, okay, to design the receiver circuit, and my approach was to design a receiver circuit that can control the bandwidth and the gain control and everything, okay. So during the viva, the external will test me, okay, did I really design the circuit or not? It will ask me, okay, at this point, if you calculate the voltage, what value, how do you determine the output graph to plot the bandwidth from your system here, okay? So these are the questions that during your evaluation research that you also must know, okay? Because the panel want to see are you really, you copy people's work, or do you understand the circuit, okay? So if you, let's, for example, modify one part of the area and then changing the circuit of the system or adding a new component, the panel will ask you why you change that, okay? Why you want to, what's the difference does it make by putting this system in there, okay? So, so these are the assessment, okay, that you need to see for the program, okay? Let's say, for example, you are faculty science computer writing a program system to run and detect something. So you need to assess, okay? So the programming that you write, is it okay or not, okay? So assess in terms of the design theory. So whatever you design, is it related to the theory from the books or not, okay? So are you using any mathematical formula from the book to calculate the value, okay? You not simply just coming up with an equation and putting values, okay? So you need to show that there's the proof of the design and theory, okay? And then, of course, the process implementation is to do the measurement output and everything. And then what is the outcome of impact, okay? Outcome of impact, okay, like for example, my design, okay, I managed to actually control the bandwidth, okay, to change from a few frequencies of the system. And then when I managed to change the field frequency, the gain also increased. So that is the outcome of the impact of my work, okay? But of course, this outcome, it doesn't have to be large, okay? Even though there's a small impact, changing from like 5 kilohertz in terms of frequency is good enough, okay? So let's say if in solar panel, you're designing a solar panel, the initial solar panel can measure until 0.6 volt. Your design by using renewable materials, let's say for example, can get a measurement of 0.55, maybe not higher than the initial, but it's still okay because you're using renewable materials. But of course, if you manage to show that your output is higher than the normal solar panel, silicon solar panel, let's say 0.65, that's much better by using renewable materials. Okay, so that's the outcome impact. Okay, and of course, there's also the cost and efficiency. Okay, of course, this is a juggle. Some panel will ask you, oh, you managed to get this output, but your system equipment all very costly. Yeah, that's why some get good efficiency, but some the system is very costly. Okay, so some manage to reduce the cost, but the efficiency is very just only very low or a little bit extra. Okay, so of course the panel will ask, but of course they will not penalize, okay, because in the end it's our system. So it depends on if you manage to get both, much better, okay. So these are the hierarchy of evaluation of the output result that you should go through and test and see, okay, this output, what does it lead to, okay? Lead to low cost or high efficiency or better outcome or better impact, okay? Sometimes none of this also occur, okay, but it's a better process implementation also it's possible, okay? Some students do get a PhD by just implementing the process, but the outcome is a bit low. The cost is high, but because of the process implementation, it's a bit different. Managed to do differently from others, so to be acceptable. Okay, so it depends on the panel itself as well. Okay, so when you get output result of your result, then you have to look through this evaluation list and see your output result goes into which category. Okay, so approaches to need assessment. Okay, so determine what is needed. Okay, so which means that have to do extra testing, okay, to confirm your design, okay, and then also allow stakeholders or others to define the problem, okay. So if you manage to design something, I know some of my friends, the design system, they send it to industrial, to ask industrial to evaluate whether industry will take this system or not, okay, and then they get feedback from the industry, what to add and what to improve so that they can use in their industry. Okay, so this is also another way of evaluation your research. Okay, also you can search for evidence of problem or lacking from other places so that you can improve your system. Okay, or maybe your system has multiple methods employed in the system. Okay, so like my system that day, I can have achieved two gain and bandwidth. So it's a multiple methods in one system. Okay? So so it depends, okay, your PhD research, what type of output evaluation that you want to show. Okay, some solving problems. Okay, some have multiple methods in one system. Okay. Some are driven by stakeholders' requests to come up with something. Okay, so so this is a way, okay, to make sure that your research have some value, okay. This one. Okay, the approach to impact. Okay, how to get impact is actually after you get your result, if you need to you start analyze. Okay, so when you do analyze, don't draw a simple graph, okay. So if you manage to draw a graph like this, okay, where the general approach compared to what happens after the program are implemented to what happened without the program. Okay, so like this lah. Okay, so so after the program, the thing will increase going up. Okay, so there's a huge difference before the program is around here. So during driving of the program and after program. Okay, so this kind of graph, okay, or output approach that external examiner wants to see lah. Okay, to show there is a difference between your research and before the research. Okay, so you cannot just like degree level just plot simple graph and then shows there's output. Okay, but to actually to show there's difference between it. Okay. So, or maybe some like most of my students, they do experimental approach. So they have one graph using experimental and then another graph from stimulation approach. So then from the two graphs, they will see whether it's different or too much difference. Okay. If it's almost near, then it's good, which means that the stimulation and the practical is almost in pair together. Okay. But if you get a graph which is too far away, then you need to look back lah. Okay, which part of the area is that causes it to be too far apart. Okay, so as from stay here, experimental approach is generally the preferred impact analysis lah. Okay, because a program in conceptual manipulation is dependent on variable. Okay, so as I say, most of the external they like to see practical approach, because if only based on conceptual or stimulation, they know we can manipulate the system to show the good result. Okay, so if those students who do not have a practical approachable, then you need to do validating some other way, okay, to show that what you have done is acceptable. Okay. Okay, this is an example. Okay. Engineering method statistical thinking. Okay, so usually most of the, if you are in engineering lah, okay, you have to evaluate something using statistical approach lah. Okay, calculate it to show the mean, the average of the system lah. Okay, so for example, this is an engineering example. Okay, suppose that an engineer developing a rubber compound for use in O-ring. Okay, the O-ring are employed and sealed in plasma etching tools. Okay, so the engineer use a standard rubber compound to produce 8 O-ring. Okay, so you cannot do one. Okay, you have to do a few different types. Okay, 8 O-ring in a development laboratory and measure the tensile strength for each specimen after immersion of after putting into nitric acid 30 degrees and 25 minutes. Okay, so this value he put in, look, he write here, refer to American society standard. Okay, so you cannot simply up to you play around what value you want to put. Okay, because you need to be reliable. Okay, so you need to tell the examiner, okay, this value I choose is according to this standard. Okay, so standard say if this type of material must be around this 30 degrees 25 minutes. Okay, but of course after testing this one with 30 minutes 25 minutes 30 degrees 25 minutes, you can change. Okay, you can put try 40 degrees then 50 degrees for 25 minutes, and then after that you can change using setting 30 degrees and then change 25 minutes 30 minutes and to see what's the change output. Okay, but the first step is to actually to have reference first, then after that you can change. To change mean is to get more variation of output data. That's why in the end you will have like 10 set of data, 20 set of data of changes of it. Okay, so and then look, this tensile strength is of the 8 O-rings are all different. Okay, you can change to different tensile strength to see what is the outcome of it. Okay. So then from there, after doing a few testing, okay, like this one, he say 20 observation. Okay, then he plot the dot diagram. okay, for displaying a small body, as I say, up to 20 observation, okay. So usually I say a minimum 10, okay. Some reference book, you say 5 is enough. So it depends on what type of test that you are doing, okay. Of course, the more better, the more is much better, lah, okay. And then this plot also allows to see two features of the data, okay. One location and the middle of the scattered, okay. So after getting data and doing annotation, so you have to find the right types of plot that you want, okay. So maybe for this this type of research, use dot diagram. Some other type we use line, some use pie, okay. Depend on your research lah, okay. So and then the dot diagram is very useful comparing the set of data, okay. So look, after that you have to have this one original, one modified, okay. So this is important, okay. It's something like validity lah, okay. That what you're doing is correct lah, okay. So the original gets around here. So after you modify by putting extra substance in it, you will go much higher tensile strength. So which means that you can tell the examiner, my work is much better by modifying, by putting extra element into the O-ring, get much better from the original. Okay? So this is the kind of data that you need to have in your thesis to prove that you are actually doing some changes, okay? The novelty of your work. Okay, okay? And then after that, after showing all those things, then you also have to do some mathematical calculation or some mathematical equation. Okay, so like right here, like since tensile strength varies, so a random X. So you have to explain some theory. Okay, why the thing become like that and why the data set that you get in. Okay, so you need to have theory, equation. Okay, formulation from it to show that it's valid. Okay, so then from there, okay, you do a type of reasoning, okay, comparing to the equation, physical law, and the product design, and your population sample and your sample. So what happened in terms of it? Okay, so so these are the proof, okay, that you have to have in terms of showing your work. Okay? So I hope everybody can get me. Okay. So from this simple experiment, okay, so you plot the result and then do comparison, okay, and then have some mathematical equation to prove the output or the data of it, okay. So this is roughly the kind of output result that examiner want to see in your thesis. Okay. So validity of measurement instruments, okay, what's validity? Like I show you just now, okay. It's a concern whether the measurement tools actually measure what they're supposed to measure, okay. One, the tools, but validity is the property of interference, okay. So is to show that that the output is correct, okay. That the value data that you pick up is correct, okay. For example, when you do the testing, let's say for example, you only do stimulation, okay. You don't do experimental setup, but you get one value data, okay. And then how to validate it? You need to compare with the previous people work, okay. Find journal, read other people's journal, and then show that, okay, previous journal, they get the value, for example, near 100 megahertz, okay. My one is almost near the value. So this is also one method to validate that your answer or the work that you have done is also correct, okay. But of course, the better one is like this now, okay. Do measurement and then do simulation and then compare. That is the best one, okay. So aspect of validity, okay. So either you use face validity, content validity, okay. Content, as I say, compare with other previous work, okay, or you do measurement and practical work, okay, or simulation work, or you use the criteria related validity. Criteria related validity means that you can refer to, like just now, standard, okay, standard from BSI, okay, British standard. I think in our library we have actually subscribed a lot of all those standards, okay, but I'm not sure how many students use it, okay, but those are the standards that you can take and be a criterion related validity, okay. Constructed validity is you need to do the mathematical formulation, okay. You construct and then you use a previous mathematical equation, you come up with a new mathematical model. That is what we call constructive validity, okay. So there's a few of these aspects of validity that you can use to validate your result, okay, to prove that it's correct. So phase validity, like just now, whether instrument looks through, it's mentioning the corporate construction, okay. So content, as I said just now, you test the knowledge based on judgment, okay, concern of the accuracy of the thing, okay. Criteria then, okay, you want to establish relationship, so you compute and compare with other previous work, correlate with instrument or other standards that you want, you have been approved by the world, okay. So like in telecommunication, we have the ITU, International Telecommunication Union, and a few of the upper IEEE electrical, okay. So mechanical, I think it's the same, okay. They have the International IEEE also for mechanical, okay. So those are the standards that you can validate, okay. So construct is the one just I say, do formulation or you do actual measurement, okay, to validate your output result, okay. Any question on this? Okay, validity of measurement instrument. To access construct validity, okay. So this construct validity, okay. So you must know the known group technique, okay. Groups that are expected to differ from attribute, okay. So you already do literature review, so you have already know which people are doing this kind of work, okay. Sometimes your work is maybe done in university survey or other university. You can contact the professor or other people there and then to ask them to validate your work, okay. Even though they're not using the same material as you, maybe the same method and everything, also you can ask them for the help to validate what we do is correct or not, okay. So we are not actually working in silo or working alone, okay. You can, like last time when I do my PhD, sometimes when I got stuck in my design, I will, if I read some other people design, I will send email to him and ask him to send me, can you help me? I'm stuck here. But of course, if he's kind enough, he will send you. If not, then he might not send to you, okay? But usually most of them are overseas, they are actually kind to share knowledge, okay? They will send you some documents to read and ask you to compare and read their work. Then you can use that as the validation, okay? Factor analysis, you can use the statistical approach, like just now, use the mathematical equation to formulate and then check your result, okay? And then examine the relationship based on theoretical prediction, okay? So summary of concept of validity, okay? So there's two types, there's objective and subjective, okay? So subjective is usually the phase validity, okay? You look at it and then you want to verify it. So that one very subjective. Some accept, some do not accept, okay? But the objective one is the one that usually people will trust, okay? Because it's construct and then concurrent and then predictive, okay? So subjective also, you can use the content validity machine that by comparing other people's work, okay? So these are the current validity method that you can use to compare your work and then to make sure that what you've done is correct, okay? So that one is validity. Reliability of measurement instrument is nothing, okay? If a measurement device is not reliable, it cannot be validated, okay? So this is more towards the, because let's say, for example, you're using the practical way to to validate your result. So you also must make sure your device is reliable. Okay. So high reliability of an instrument provides no evidence of validity. Low reliability evidence is low validity. Okay. So sometimes the instrument also can be reliable without valid. Okay. So that's why make sure that you how to be reliability of the equipment is to do the 20 times 10 time measurement repeatedly so that it's constant value that you get. Okay, so that's how you make sure that the instrument is reliable. Okay, but we mean consistently measure accurately, so validity measure what it's supposed to be. Okay, so that's how you check reliability of your equipment that you're using. So that's why that's how students ask me how many times. The more time, the better, lah. Okay, so that your equipment are all reliability. Okay. So validity versus reliability. Okay. So of course, to make sure that your work is properly accepted, to have both together, valid and reliability. Okay. So if you can valid but not reliable result, or the sources that you use to valid is not reliable resources, also cannot be accepted. Okay. For example, you refer to a sources that is totally different from the method that you're using, or totally different, is not really a valid result. Okay. So if you want to compare with other people's work, must have some similarity in terms of setup. Okay, even though, for example, the material is not the same, but the setup is almost the same, the parameter used the same, then it could be used as a valid for your result. Okay. Okay, example of validity, your result. Okay, this one that day my student was doing the image processing. So they always like to use this image, the linear image. Okay, so when I ask why use this linear image, they say this is a standard image that most of the image processing people use. Okay, so he will use this and say, okay, with noisy image like this, state of art, very clear. Okay, so then he was using this contour method. Okay, so when he used contour method, when he add in, you can put it as our method. Okay, so then you compare with other types, then you can say, oh, okay, compare the noisy image, ours is much better. Maybe compare with the state of art is not that good, but it's still much better than noisy image. So our method can be used as one of the method for image denoising. Okay, so for example, this is how it works. Okay. Another way is like this. Okay, so you can see you plot many. You can take from previous paper. Okay, and then the last one, then you say, okay, our work. Okay, from our paper, the top one. Okay, these are from other people work. Other people work is almost similar to your work. Okay, so then when you plot, they can say, oh, okay, that you have the same pattern as the rest of the people's work. Okay, so number one, that one can be validated that your work is correct because you have the same trend of graph from bottom going up. Okay, okay, and then this one show that your output is much higher than them, showing that, oh, your work is much better. Okay, so this is one way lah. Okay, but sometimes students do get graph which is lower than previous work. It's also fine, but at least the trend is correct, showing that your work is correct. Okay, maybe your graph is not better than one or two papers, but it's much better than a few other papers. It's also acceptable by panels. Okay, so this is one method to show that your work is much better. Okay, so all my students' thesis will have this graph in their last of chapter 4. Whichever method whichever method they show, all of them will have a plot of this graph among other people's work to compare that, to say that this one is much better. Okay. Okay, so I think 4:30. Okay, I think I will continue on the discussion for tomorrow. Okay. Is it okay?
Okay, Prof.
Okay. Before we go, I want to show you the assignment. I'm not sure you all have managed to access the assignment or not. Let me stop sharing this. Okay. Any question? I hope you understand. Okay, let me just brief you on the assignment. This is not the assignment. Hilang mana ni? Oh no, where is it? Are you able to access the document not, for the assignment? You see the slide? Can see the PDF file. Can see the PDF file, not? Everybody see the PDF file? Okay.
Yes,
So
Prof.
go to the Google Drive page, and then you can download this assignment. Okay. So the title is Analyzing, Interpreting, and Presenting Research Findings. So the objective is to train you all to how to present the result clearly, and then how to interpret them. Okay. So there's part A. Part A is actually to show me how you can present the result that you have. Okay. So each of you are all doing PhD, master already, so you might have some result already. So just use them and then show me how you can present your result by summarizing in a democratic form using table or chart. Okay. And then using this at least one descriptive analysis, okay, to show how to present this finding, okay, and make sure that you label everything, figures and labels properly, okay. So and part 2 is more on the discussion. This is tomorrow. I will continue on the discussion, how to write discussion things back, okay. So from the graph that you have generated from part A, so then you have to explain, okay, interpret the discussion section, interpret the finding, and try to compare the result with either using existing literature or whatever resources is, okay. So you can write it in around 1,000 to 2,000 words, okay. So the content must have result, discussion, and a few reference, okay. So this is a total 100 marks, 60 marks for the discussion and 40 marks for the result presentation. Okay. Okay, any question? Yeah, Jasim?
Yes, Prof. I just would like to ask about the submission date and how many pages we have to write.
There's no how many pages. It's 1,500 to 2,000 words. Okay, so if you, let's say you want to present to me one set of data, then do the one set of data, and then you discuss the set of data to me. Okay, so if you want to present a small amount data, then make sure it's clearly explained. Okay, if you want to present more data and you want me to check and see whether it's okay or not, then it's up to you.
Okay,
there's no how many pages.
Okay, so it's clearly specified by the number of words.
Yeah, specified by number of words. Okay. So all my students always like when they ask them to write the thesis, they always ask me how many pages. I think there's no how many pages. Write whatever you have done throughout your PhD work. You want to present anything, you present everything. Okay. So it's not how many pages that is determined. It's the quality things that you want to put into your thesis. Okay. So as I say just now in the early of my presentation, there's one of the friend who have 2 thick thesis submitted. She failed the exam. Okay. So doesn't mean you write a lot of things, it will pass the examination. Okay. So it's based on the quality of things that you submit. Okay.
Yes, all clear. Also, Prof, there is another question.
Yeah.
For me, in my condition, I'm a new master student, and I'm in
Okay.
the proposal stage, so I don't have an actual data results. So how can I?
Well, you can if you are in a new student, you have read some papers, literature review. Okay, so maybe you can just take one of the journals of their data and then try to rewrite yourself to present the data. It's also fine.
No, that's clear.
Okay, yeah, it's also only a practice to see how not to show me the journal's writing. Okay. but you can like for them take one or 2 graphs of it, and then either you modify it and then you relabel it, okay, and then you write your own discussion on what it's explaining.
Oh,
okay.
That's good. So I take one of the existing research and I take their data and based on my understanding. That's clear.
Based on your own understanding and how, if you have this set of data, how you're going to present it.
Yes, that's clear. Thank you so much.
Okay. Yeah. Anything else? Can we do assignment following your own field? Not all of us are from engineering field, right? Why not from our engineering field? I see. Yeah, you can from your own field. I don't know, Siti Haja, you're from where? What are you doing, Siti Haja? Biodiversity. Yeah, it's okay. Biodiversity, you can biodiversity. If you want, if you have any result on going to the forest to collect butterflies or any, I don't know, if you're looking at elephants, you can use the data set to explain. It's okay. Okay, Siti Haja? Okay, fine. Okay, anything else? Submit date. Submit date. I think before end of this semester lah kan, betul nak Hadilah? Deadline submit for
15 January.
15 January. Okay, 15 January.
Is it sufficient time for you, Prof, to
I think it's okay. I think it's okay. Yeah, no problem.
okay.
Okay, so then I'll see you tomorrow around this time for the last part of discussion. Okay. Okay, so tomorrow also important discussion. A lot of students do not write good discussion. Write too simple discussion also will face problem during Viva. Okay. Okay, so thank you. I'll see everybody tomorrow. Assalamualaikum. Dr. Nolita, anything to say?
Okay, thank you, Prof. Hopefully, Prof can share the notes today or tomorrow.
The notes also inside the Google Drive already.
Okay, so you already shared the Google Drive link, Prof?
I share to you, then you send to them because I don't have. I'm not.
Okay, okay, Prof.
Yeah,
Okay.
I'll send to you and then I'll send to them.
Okay, thank you, Prof.
Okay.
So we will meet again tomorrow for the second session.
Okay, no problem.
Assalamualaikum.
Assalamualaikum.